problem. Okay. So gravitational forces was in progress, and I told you about that the basic concept of the gravitational force was basically discussed by Newton's. That is, the formula for the gravitational force was G m1 m2 divided by r square. And according to Newton's law of motion, that if we have a body that is a single body, and we have discussed that all, that definitely these two bodies will attract each other, and this attraction will be equal in magnitude but opposite in direction. So this is the force of gravity, which is exerted by m1 into this m2, and the separation between the center of these bodies is from this point to this point. You got it? This is the separation actually. So that is equals to r. Now I will talk about another situation, very interesting situation. That okay, if that body is moving away from the mm, from this, that was at rest, so it was having the maximum force. But once the body is moving away, I discussed that, but just I'm connecting the new topic with this one. So this is, let's say, the planet, and let's say this is its r, this is its 2r, this is its 3r, this is its 4r, this is the 5r, this is the 6r, and this is the 7, and so on, so on, so on. So I told you that the force will be maximum, and when at r, let's say the force is F, any value of the F, so it is 1, 2, 3, 4. Let's say it is here. So when the distance will be double, it will be 1/4, and for distance for nine, three times it would be 1/9, and so on. So this would be decreasing. Yani the gradient would be becomes constant, and so on. So in this way, you can simply say that this is the graph of force for a single body. Then it is moving away from the mass. Yani a body is moving away from the surface of a planet in this way. But there is another issue. If you have 2 point masses and there is a test mass, then what will happen? Right? Then uh, what what will be there? So today's topic is that an object moving between 2 point masses, right? A test mass is moving between 2 point masses. So basically, the question is now switched, or the topic is now switched in this way, that force due to, do you have my voice clear?
Yes, sir.
Okay, the force due to 2 point masses. So, uh, as I told you, that the force due to 2 point masses means that the 2 point masses will be basically having, these can be two planets, right? And if we have the two planets, let's say here is planet A and the other planet is planet B. Let's say this is planet A, okay, and here is planet B, and this is a smaller planet, let's say, and the separation between these two planets is this R, okay, right? And there is a, it is basically on the line joining these two planets, right? I have just placed this mass at different positions, okay, and let's say it is here, and let's say it is here. So these are some important positions right now. This is its position 1, then position 2, then position 3, and then position 4. Now, if I say that this blue planet will attract this small mass towards itself, right? The force will be, because this object is closer to uh, planet, this planet, yani let me call it MA. This planet has a mass M1 or MA, you can say, and this red one is having MB or M2. Simplifying this concept, I am writing this, that this is MA and the other one has MB, right? The masses. Now, I will simply say that what will happen to this point? This is a small m, right? This body is basically your small m. Yani this is any a test mass. Okay, point masses, and this is the test mass. So the force will have the behavior. The body is closer to this, so there would be greater force from this planet. So as it is moving away, the force will be reducing or decreasing, right? And decreasing and decreasing, right? And now it is almost very small. But the force due to that red planet, it would be smallest here, right? It would be larger here, it would be larger here, and it will be largest here. You got this whole situation? Yes, yeah, yeah. And Lulu, did you join me?
Uh, she didn't.
Okay. So here I intentionally put these two forces equal, right? Because there will be a point where these two forces will be equal to each other. So here I'm just going to mark these forces. This is the force of planet A. So let's say this is F1, right? And this force is due to planet B. So let's say it is F2. Both forces are opposite to each other. And let's say this is F net. F net is equal to what? That is F1 minus F2, or Fa minus Fb. So that means the resultant force that will be acting on this planet, that will be in this direction. The difference of these two. Okay? You got the point? Here F net is 0. Here it increases again and again and again in this way. This is basically the main concept of fnet, that fnet is increasing again. Here fnet is 0, so I'm just making a dot. So all these situations must be taken care, that here at this point basically what happens, fa, the f1 is equal and opposite to F2. That is why, what about Fnet? Fnet equals to 0, isn't it? And that body is in equilibrium over here. You got this point? Is this point clear to everyone? So Fnet equals to 0. So when
Yes.
Fnet equal to 0, you can simply say that yes, I can use this logic of f net equal to 0 for my calculations, that there will be no acceleration of the body. And when there will be no acceleration of the body, basically that all can be utilized, or you can manage this all in terms that yes, the body is having a sort of resultant acceleration went to 0. So I will be back on this point. Now I will be talking about that this question is asked in the three, four different ways. One question, yani one way to be asked this question, that is actually, Assalamu alaikum, Lulu. Sorry, I just noticed that you need permission. Yes, Lulu, are you there?
Yes, sir. Thank you,
Sorry,
sir.
I to make this meeting open for everyone, because sometimes I do not notice that someone is waiting in the room. That is why there is a problem.
Okay, sir.
Okay.
Yes, sir.
Okay. So how many times did you join?
I tried twice. The first time I waited, but then the second time is when I joined.
Oh my God. So
Yes, sir.
okay, next time I will try to make this link more open for everyone. Okay, so this
Okay, sir.
was
Thank you.
the topic what we were talking about. In the last discussion, we discussed that gravitational force have this behavior, that the force decreases with increase in distance, and it follows inverse square law. And this was basically the Newton's law of gravity, which I have stated here. Okay, and furthermore, if we say that yes, move now, this is basically today's discussion, that two bodies are there, two masses are there, and there is a point mass, this black one, that is moving in between these two planets, and the force of the blue planet is towards left, and the force of the red planet is towards right, and the net force is black, so that is the difference of these two. This is very important point, that what is the net force. Net force is basically the difference of these two forces which are actually in different direction. So if I simply say that yes, this f net is in different conditions or in different positions, it will be different. For example, at point 1, you notice that f1 is greater than f2, so that is why what was happening, that there was a resultant force towards left. Okay, are you getting this point?
Yes, sir.
And at this point, both the forces are equal, so F net equals to 0. Then F net is reversed in the direction. So now F net is in this direction. So that is the point basically what is asked to you in exam. Okay, that here basically F net is F minus F2. So this is actually in this direction, opposite direction. You got this point? This way.
Yes,
So
sir.
this is all what we have learned till you were going to join my class. So I will continue right from this point. That actually the I was talking about the questions which are asked from here. The questions asked are of three types, rather four types, but yes, these questions can be of three types. This question has a link with gravitational field strength, the gravitational force. You are asked that, okay, describe the variation of gravitational force, right? Gravitational force description or variation. 4 marks question is observed in past papers, right? This is 4 marks question, and these 4 marks are justified here. First of all, you will say that the force, the forces are opposite to each other, isn't it? Na? The forces are opposite to each other. So the resultant force is the difference of both forces, right? Is the difference of, because you will not have the diagram to explain. It would be just yani question will be given to you and you will be asked to answer that. And the resultant force is the difference of both forces. Okay. Now, right after this, what will you write here? That F resultant or resultant force decreases to 0 where both the forces become equal and opposite. Sorry, where both the forces become equal and opposite. Okay, are you getting this point? The point where both the forces become equal and opposite, what happens? The force will be 0. You got it? Then it increases again. Then F resultant increases again, but opposite in direction. Or you can simply write increases again in opposite direction. In opposite direction. Is my voice clear?
Yes.
Yes, sir.
Okay. So these are the points what you have to mention by all means. Right? Is this question clear? Description. Will you be able to write it? Yani This is basically you have to give the behavior of the forces. Okay. Second is you have to make some calculations based on this, right? The calculations based on this, they are very important calculations and they are asked to you. The calculations are, if I say that at the null point is basically that point where both the forces are equal and opposite to each other. Okay? Both forces are equal and opposite to each other. That is why, what do we think or what do we say that FA or F1 is equals to F2, because both the forces are gravitational forces, attractive forces. So I can say that this was basically G mass of planet 1 into mass of the test mass divided by R1 square, and that is G M2 small m divided by R2 square, right? This is the point where both the forces are equal and opposite. So let me mark this distance from this point to this point. The total distance is what? Total distance is, this is the total distance. So what is this total distance? That distance is x. And what about the remaining distance? This one, that distance is basically r minus x. Okay, because total separation between these two planets I told you about, that was r. Okay, ji? That total separation was how much? Total separation was r. So that is why I'm going to write it, let's say R1, and I'm going to write it R2. Where R2 is, if this R1 is equals to X, then R2 is R minus X. Is this very clear to everyone? Both of you? Is it clear?
Yes, sir.
So I can simplify this, that now this is G and G will be gone. It will be cancelled out. Small m and small m is gone. Now the variables are left over, mass of planet 1 divided by x square equals to mass of planet 2 divided by r minus x square. Right? So this is the ratio which gives you very interesting information, and that information is, you can calculate the ratio of masses. Okay, from this topic you can calculate the ratio of masses of two planets, and most probably you can calculate the distance of null point, right? What you can calculate? You can calculate the distance of null point. So I can say that from here, this is mass 1 divided by mass 2, that is equals to x square divided by r minus x square. Or if you just go one more step ahead, so you can simply say that it is m1 divided by m2, that is equals to the ratio of x divided by r minus x whole square. And this question has this calculation. Yani, two types of calculations are then asked to you. Calculation number one, that you can calculate the individual masses, right? The ratio of masses. The ratio of masses is very simple to calculate, but for distance calculation, you will take square root on both sides. And when you will take square root of both sides, it will be m1 divided by m2 square root, right, into r minus x. So actually, I do not want to write all these equations here to just make complications for you. So you can simply plug in the values. You will just see that yes, there are some questions in which we are going to do this all, and then this calculation pattern, and you can calculate the ratio of the masses and so on, right? So you can simply use this question for two, for yani this expression for two things: ratio of masses. Okay, Lulu, are you getting this point?
Yes, sir.
And secondly, the distance of mm, zero gravity from any of the planet, right? So the third aspect of this graph or this topic is graphical analysis, right? What is the third aspect? That is the graphical analysis. Actually, graphical analysis means that you people will have to draw the graphs, and these graphs should be based on some, you know, logics. This was planet A. Let's say there would be planet B. I'm gonna erase this till this point. Oh, sorry. This was my planet A because I had just considered that this is planet A. This was my planet A, or planet mass A. This was my mass B. Now, for example, I told you that the force of A will be maximum near its surface. So suppose it is at this point. So one, two, three, four. Let's say this is. Let's start it from four. Right. Right. So after, as the distance is doubled, right, it 2r, it would be reduced to half, and then half of this, and so on and so on. So you will simply draw this graph in this way. Okay, so if I say that just reducing this curve, I'm just gonna draw a graph in this way, right? This is basically force of planet A, blue planet. Then for red planet, the force will be maximum at its surface because that planet is smaller, but the force will be equal and opposite to each other. So that is why, yes, this is one very interesting thing. This is not the force of the force of these two planets is ignored for each other. So you can simply say that okay, it does not matter that they are having this much force or not. So this is basically force of planet V, F2, and this was force of planet A, F1. Now, what will be the resultant? As I told you that the resultant is difference of these two. So did you notice almost at this point, both the forces are equal and opposite. So that is why your resultant will pass through this. It will increase again and it will be in opposite direction. You notice this point? This thing? So this is the graph which is asked to you. Okay? You can draw the individual graphs or you can simply draw the resultant graph. Is there any confusion or question from this topic?
No.
No, sir.
Okay, I will just link one more topic with this one, right? And then you people will say that, okay, the two things can be calculated directly from this. One more issue, that is of the gravitational field strength. Although I'm not going to talk to gravitational field strength in detail over here, but I say that gravitational field strength, by definition, gravitational field strength is the same thing. Okay? Gravitational field strength follows the same pattern. And that means that if you have the gravitational field strength, that is basically the force per unit mass, right? What is that gravitational field strength? That is defined as, yani this is represented by G, and it is represent. This is defined as, or its unit is Newton per kg. Okay, and this is basically field intensity. So I can simply say that gravitational field strength is the force per unit mass. Okay, simple. By definition, it is. But for exam definition, it is the force, the gravitational field strength at a point is, right, because the gravitational field strength varies with the position. So gravitational field strength at a point or at any point is the force per unit mass. Don't write per 1 kg, per unit mass at that point. Okay, that is of 2 marks definition. Right now, I have its defining equation, and then that defining equation is basically simple. That means that gravitational field strength is represented by G, and that is equals to force per unit mass. That is why its unit is Newton per kg. But what force do we have? We have the gravitational force. That is why it will be minus G m m divided by r square into, this is that small m. Okay, and then you will just cancel all these things, right? This m will go on with this m. So this is very simple derivation, but very important, that the gravitational field strength can be written as negative G m divided by r square at the surface of any plane, right? At the surface of any plane. Okay, is it clear?
Yes, sir.
Okay, you have to recall this formula, and derivation is also. It means that gravitational field strength, this is very important point here, some improperties of this, that G is independent of small mass. What is this small mass? If I draw a diagram here for you, this was the planet, and its mass was capital M. It was concentrated here, and this was the object whose mass is small m, and the separation between the centers is, let's say, small r, or you can say capital R. Okay, let me, yes, this body is at the surface. So this separation is basically equal to capital R, equal to the radius of this surface, or equal to the radius of this planet. So that is why it is independent of mass of the object, mass, test mass. Okay. Secondly, value of G is maximum at the surface. At the surface of a planet. Okay.
Okay.
Third, yes. Any question?
No, sir.
It decreases by inverse square law. Okay. By inverse square law as the distance increases, separation increases, or you can say separation increases. Okay, then there is one more important property that G is based on capital M, mass of the planet. So that is why mass and size of the planet. Size of planet. Are you getting my point? So that is why different planets have different masses, different values of G's. You got it? Is it clear? So
Yes,
if
sir.
I say that G has a variation, right? Here I'm just going to write one point that variation in G, variation in G. There are 2 points for this one for variation in G. One is above the surface and one is below the surface. Right? These are two very important points that the variation of G is basically of two types. Okay? One is below the surface and one is above the surface. So let's talk about first one, uh, above the surface wala. And if I consider a body or if I consider a planet like this, and now the mass has reached to this point, right? The separation between these two is now equal to this is the radius of this planet, and this is basically the height above the surface of this planet, which is significant, right? That is why this this height or this separation is now equal to r, which is equals to capital R plus h. Is it clear or visible to you?
Yes, sir.
Okay. This is basically capital R plus H. Now the problem is, if I just consider the if I just consider this all, that variation above the planet, this is basically the point what I'm going to explain now. Above the planet. Okay, so as I told you that G at certain height, it is called variation with altitude, right? What do we call it? Variation with altitude. Okay. Now moving on, the value of G is basically negative G M m divided by, sorry, negative g m divided by small r square, where that small r, you know what will be that small r? That h is equals to minus g m divided by capital R plus h whole square. Capital R plus h whole square. It means that this, as h increases, the value of g decreases. So that is one of the concept, but is very simple to understand, that as you increase the h, value of g decreases. Okay, so it follows basically inverse square law. That is why I will completely draw a graph, but you have to keep this one point, that the height, as the height increases above the surface, that decreases, but as the radius increases, yani small r, this is actually separation, not radius, then value of g decreases by inverse square law. Okay, by inverse square law. Now there is one important derivation here, which is named as below the surface. I will consider that derivation for you if you just give me 5 more minutes. Below the surface. Okay, when I say that the variation of the G decreases below the surface, I have to give you a diagram, and that diagram must be, you know, it must have a clear concept that, let's say, this object is now, we are going to drill into this earth, okay, or in this planet, and that object, it is just say that this is a small object, this one. Now this object was at a separation r from the center of the earth, is it? Now I'm just going to magnify the diagram just to make you clear, then I will be back to this point. Now the separation from the center is almost this, almost this is the center. Okay, now just consider that the earth has been just digged in like this, and this is the level where your people reach after digging the earth down. Okay, is it clear? Now the distance between the distance walked through is, let's say, this distance. This is basically the deep depth digged into, whereas this total was basically, yani total from this point, this blue arrow, that shows capital R. And now the remaining distance for the internal earth, yani you can simply say that now the external earth is just gone for this body. It does not matter because it does not have any center. So this is R minus D. Got this point? Is this clear?
Yes, sir.
Okay. So if I say that now this object is basically, this was here, and now this object is at this point. So when this object is at this point, definitely there will be some variations of the force for this object, and those variation of the forces are considered here. Now I'm just going to read, evaluate, or tell you all these points. Now the variation, or the G, is basically equals to G M divided by R squared. That is G m divided by minus d whole square. Now, as you know that the value of the earth or the mass of the earth, this is the derivation for density of the earth also that is asked in your exam. The mass of the earth is equals to density of the earth into volume of the earth, which is equals to density of the earth into, you can say density in this way, density into volume of the earth is 4 pi 3 pi r minus d whole cube. You got this point? Now you will substitute this mass exactly in the above equation, and you will see that yes, now the equation of GD, I mean value of G in the depth, is now framed as 4 pi r minus d whole cube divided by 3 from this formula, and here it is r minus d whole square. So basically, this is one quantity, this is the same quantity. So they will be gone. So you are getting that GD is equals to 4 by 3 pi G into R minus D, which was basically what? The value of GD is equals to 4 by 3 pi G into R. So please remember this concept. It is very interesting one, as well as it is asked to you to calculate the temperature. Oh, sorry, here was another value, the density of the earth. The density of the earth. So you can calculate the density of the earth. Okay. From these two values, I will just rearrange this whole concept that below the surface, the variation or the G is directly proportional to small r, and above the surface it was inversely proportional to square of r. You got this point? This is G at height and this is G at depth. If I join the both concepts, and I will be giving you a simple logic behind this, it means that is, let's say I have a planet, and for this planet has center, or this planet has some radius. Okay, right? This is the basically planet's radius. So value of G is maximum at the surface of the planet. Let's say it is here, right? It is here. This value is equal to G at the surface. Then above surface, it follows inverse square law, and till center, it follows the directly proportional. So G is directly proportional to R below the surface, and G is inversely proportional to R above the surface. Is this clear to everyone? So
Yes,
if
sir.
there is a past paper question, and in that question you are given a planet, and you have a graph like this, and it is said that okay, the value of G is basically, you have to draw the value of G here on both the sides. So on both the sides, it will be very simple that the value of G will increase on that side, and it will basically decrease like this. And on the other side, what will happen? It will, because that is also considered as a you know, we can say that it is a vector quantity also. So sorry, That will be in this way. So these type of questions are asked to you, right? Remember this thing. This is the value of G below the surface from center to surface. The same goes here, and this is above it. So this is basically R, and this is value of G. This is R, and this is value of G. This is exactly a past paper question I have given in the test one test. Okay, so we will discuss this all in the next part, inshallah, next part of the discussion. Hopefully, this all went well to you. Although that topic was a little bit tricky, but it does not matter. You people will get it, inshallah.
Okay, sir.
Okay, see you then, inshallah.
Thank you, sir. Bye, sir.
Allah Hafiz, Allah Hafiz. Yes, where is? Yeah, 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 yeah.